everybody. Today we're going to be looking at character sets. This is relevant to all GCSE specifications, and my name is Josh, and I was a computer science examiner for over 5 years. I was a head of computer science for a number of years as well, and then I run a tutoring business now. And this series of lessons is all to do with giving you as little as possible to remember whilst being able to still get the top grades. So if we look at the different spec points, this is AQA up at the top in the purple. You've also got Cambridge International, and then you've got OCR. So we're going to be going through these ones. So the questions that are associated with this one, which is describe what a character set actually is. So a character set are the letters that are represented on a keyboard and the binary numbers that are associated with them. ASCII and Unicode are examples of them. We also have to have a look at how many bits are in standard and extended ASCII. This is relevant, so for extended ASCII, this is relevant for OCR and Cambridge International. AQA, you only need to know standard ASCII. So standard ASCII is 7 bits per character, which this allows for 128 characters. The way that we work that out is we do 2 to the power 7, and this gives us 128. So 2 times 2 times 2, 7 times. Extended ASCII is 8 bits per character, so this allows for 256 characters, which is 2 to the power 8. We'll come back to this in a little bit about why there were some problems with extended ASCII, and we had to switch to Unicode. How many bits are in Unicode? Whilst I don't necessarily think this is going to be a question that's going to come up, what I want this to illustrate is that Unicode has a lot more bits associated with it, and later on there is a question which is quite likely to come up, and I want you to just know Unicode has more bits. Generally, you just need to know that it's got between 16 and 32 bits, which allows you to represent many more characters, but it's not absolutely essential that you remember that. There is also a question where they might give you a sentence, so in this case I've gone for hello Josh, and what they'll ask you to do is say how many bits are used in this statement. Now, what you have to do is you have to count the number of characters and any punctuation. We're going to leave out the speech marks because that's just the thing which is enclosing it in there. And what we have to do is we're going to go for the space in between there. So that actually counts as a character, and then all of the letters. So we go 1, 2, 3, 4, 5, space 6, 7, 8, 9, 10. So we've got 10 characters there. And if it's written in standard ASCII, we have to remember that it's 7 bits. If it was extended ASCII, 8 bits. It's unlikely that they would say it's Unicode, but they would tell you how many bits are going to be in there if it was. So we do 10 times 7, so that's going to be 70 bits there. You also have to know that the letters run in sequences. So I've put a capital B there as 66 in ASCII, so they'll tell you this, and they'll say, what is the ASCII code in binary for C? So you need to use your logical part of your brain to understand that C, logically, is 1 after B. So that's going to be 67. Like, logically, uppercase A, and know that I'm distinguishing between uppercase and lowercase a. Uppercase A is going to be 65 because that is 1 less than that. So 67, and then we just convert that into binary, which is going to be here. Here, I've put how many characters does extended ASCII allow for. Just to sort of go in a little bit more detail about this, what they might ask you to do is say how many characters this does. So the way that you do it is you do 2 to the power 8, which allows you for 256 characters. What this means in a little bit more detail. So if you find that a bit confusing, just remember 2 to the power 8 or 2 to the power the number of bits, and that will give you the number of possibilities available to you. How it works though is you've got, if you imagine 0, and then if it was all 1s in a binary number, so 8 1s, that's 255. So 0 all the way up to 255 is 256 possibilities that you can represent with that. So that's why each character is going to take up a number, and that means that we can do 256 different characters with 8 bits. The final question is, why do we use Unicode over ASCII? So because Unicode has many more bits, and this is linking this back to what we were doing earlier, Unicode, there was an issue that generally character sets were only based on the European alphabet, so European style alphabets, which is fine, but as computers started becoming used more around the world, this was an issue. And what we had to do is we had to extend this so that we had space to be able to have different characters for the Japanese alphabet, or Mandarin. So we were able to include all of those different features with Unicode, and then we started adding in things like emojis. So the answer that you're going to give is Unicode allows for more characters as it has more bits per character. We didn't have enough characters with ASCII for the other languages alphabet that didn't use European alphabets. So what I'm doing there is I'm really explaining it. I'm showing off what I know. I'm saying that it has more bits in Unicode, so this allows for more characters that are nothing to do with the European alphabet.